Okay, in the last video we talked a little bit about the decimal system that you grew up with and you've known all your life. So then we looked at just a little bit of the binary numbering system, and we converted a binary number into a decimal number. So in this video though, we're going to talk a little bit more about the binary system, binary numbering system, and we're going to convert a decimal number to a binary number. So sometimes communicating with computerized equipment is easier if you know a little bit about the binary numbering system. So let's convert a number, a decimal number, into a binary number. And we're going to use the number 179. We used that number last time, and we're going to use that number again to convert from decimal to binary. So in any numbering system, the first digit in the base is the base to the 0 power. So the first digit here is the base 10 in this case, to the 0 power, which is the ones digit. We covered this in the first video, and the second talked about how the second digit then is the base, which in this case is base 10, would be to the first power. And let me go back and add this here. This is 10 to the 0 power. And the third digit then would be the base 10 to the second power. So and it follows that same pattern with whichever numbering system you're using. So in this case we're going to be using the binary numbering system, and if we look at the digits in a binary number, we'll pick a random binary number here, 110 1110, maybe. Let me clean that up a little bit. We'll go back and make that a little neater. 1110, maybe 1100, something like that. We want an 8-bit number, so it constitutes a whole byte, and we'll get into that a little bit later, the difference between bits and bytes. But right now we've got 8 bits here in the binary numbering system, and this first digit here then is going to be 2 to the 0 power, because this is a base 2 number. This digit here is going to be 2 to the first power, 2 to the second power, and so on. So if we look at those numbers, 2 to the 0 power equals 1. Anything to the 0 power equals 1. 2 to the first power equals 2. 2 to the second power equals 4, and so on down the line, each time doubling again. So 2 to the fourth is 16, 2 to the fifth is 32, 2 to the sixth is 64, 2 to the seventh is 128, and 2 to the 8th power then is 256. Okay, well in this conversion that we're going to do from 179 over here, convert 179 into binary, we don't have to use 2 to the 8th power, because that's equal to 256, and that's greater than our number already. So we can see that it's less than 256, so we're not going to need to use that digit. But it is more than 128, so we're going to have to use 2 to the 7th power. So if we go back over here and look at these, you know, this is 2 to the 3rd, then 2 to the 4th, 2 to the 5th, 2 to the 6th, and this last digit here is 2 to the 7th. So this digit here is equal to 128 in decimal. So if that digit is a 1, then we say that that bit is set. If that digit is a 0, like it is over here, then this bit is not set. So since we're only dealing with either 1s or 0s, they refer to them sometimes as this bit is set, and a 0 means that bit is not set. So if the bit is set, then we would add in its value of what its equivalent is in decimal. So to convert this 179 over here, we know that it's more than 128. So we can take 128, we can take the 179, and we can subtract 128 from it, and we're going to be left with 51, right? Okay, so if we were looking at an 8-bit number, 8-bit binary number, then we're going to set that first bit. So let's set the first bit. The next bit is equivalent to 64. So we've only got 51 right now. So we don't have enough to set the next bit. So let's make the next bit a 0. So we've got the next bit is a 32. So if we subtract 32 from 51, we've got enough to set that bit, and that's going to be, let's see, 19, right? So we're going to have 19 left over. So and we're going to set this next bit. So this is going to be our 128s. This is 64s. This is 32s. Next bit is going to be 16s. How many 16s do we have? Well, we've got 19, so we've got more than 16, so we can subtract 16 from the number. That'll leave us with 3, and we can set the 16s bit. Okay, how many 8s do we have? We've only got 3, so we don't have any 8s, so we put a 0 here. How many 4s do we have? Still don't have enough, so we put a 0 there. How many 2s do we have? Well, we've got enough to subtract 2 from this, and that leaves us with a leftover of 1. So we can set the 2s bit, and we could also set the 1s bit. So a little tip here, that anytime you have an odd number, anytime you start off with an odd number, you're always going to have that 1s bit set. So this is our binary 8-digit number that would be equivalent to 179. Okay, this is base 2, and our equivalent number was the 179 in base 10. So now you can see this is just one method to convert decimal numbers into binary numbers. And there are other methods out there for larger numbers, but with smaller numbers, this is a pretty quick, easy method to use. So you try a few on your own for practice, and we'll see you next time.